Torque. When a car drives down the road, the body of the car is undergoing translational motion, and the tires are undergoing rotational motion. In translational motion, all points on a body travel in parallel paths, and the motion is due to a force being applied through the center of mass of the body. In rotational motion, as with the tires, an object rotates around a fixed axis, and the motion is due to a force applied on the body, but not through the center of mass. The rotational effect caused by a force applied at a location other than the center of mass is called torque. Torque is also sometimes called the moment of the force. Torque is usually written as the Greek letter tau. A greater applied force has a greater rotational effect, or torque. Take the example of a door on a hinge. The hinge, in this case, is centered on the axis of rotation. A greater force applied to the door makes it move faster around the hinge. How fast it moves around the hinge also depends on where you apply the force to the door. A force is applied to a rotating body along what we call the line of action. It's a line that extends out from the force vector. We call the distance from the rotation axis to the line of action the lever arm, L. The lever arm is drawn at a 90-degree angle to the line of action. So, if the force was applied in this direction, this would be the line of action, and this would be the lever arm. There's a special case in which the force is directed in line with the rotation axis, so that the line of action goes through the rotation axis. In this case, the lever arm is equal to 0. The magnitude of the angular acceleration of the door is greater when the force applied to the door is greater, and when the lever arm is greater. This means that both of these things also make the torque greater. In fact, the magnitude of the torque is equal to the magnitude of the force times the lever arm. The value of the torque is positive when the force applied causes a counterclockwise rotation, and it's negative for a clockwise rotation. Since torque is in force units multiplied by length units, it's in units of Newton meters.